Hello everyone, this is Deepak Joshi, and today we are going to solve a very easy question on LeetCode, that is middle of the linked list. We need to figure out the node that is in the middle of the linked list, right? Okay. Now, how we are going to resolve this particular problem statement? Let's figure it out together. In this particular problem statement, we have given a linked list having different nodes, and we need to find out the middle one. It's as simple as that. Like, this is the problem statement. Now there is one brute force approach that we can implement, but I'm not going to implement that right now here. I leave it to you that you guys should implement that particular brute force approach. The approach is um, yes, the approach is first calculate the length of the linked list. Let's say here in this particular given example, we have five nodes. So what we are going to do is we are going to calculate the. Let me check whether my yeah, okay. I was just checking whether my Bluetooth are connected to this. If that is the case, then my audio will be a little janky. Okay, so I was talking about the brute force approach. The brute force approach says that what we are going to do is we are going to just simply calculate the length of the linked list, that is five in this particular case, and then we are going to divide it by two. If n or the size of the linked list is odd, then we are going to add n by 2 plus 1, and if the size of the linked list is even, then simply go to the. Let me check for the even one. It says again, if the size is 6, again go to n by 2 plus 1, because 6 by 2 is 3 and 3 plus 1, and return the n by 2 plus 1th node. And how we are going to do that? What we can do is I can even increase, make it the worst code ever. What I can do is I can have an array as well. To I'll calculate the size and put all the elements in the array itself, and just return the n by 2 plus 1th element directly as a node, list node. But that will be a very worst scenario. Instead of using an array, what we can do is just calculate the size, and then I start iterating again from the head, from the starting position, and iterate till and take count, and iterate till count becomes equals to n by 2 plus 1. This is the brute force approach, or a step ahead of the brute force approach, if we consider that using of array as a brute force approach. All right. Okay. And now the optimized approach for this particular problem statement, that is there, is an algorithm, tortoise and hare algorithm, that we are going to use. I know, I it took me a while to remember this name, tortoise and hare. No issues to remember this particular algorithm's name. What it says is it is a very easy algorithm. Like, we will have a tortoise and a hare, कछुआ और क्या बोलते हैं उसे, रेबिट का बच्चा, yes, खरगोश का बच्चा. Am I right? What is rabbit's child name? Kit or kitten? Then what is here? What is here then? Okay. Okay. Genus Lepus, they are herbivores and la 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 la. Okay. Is here a rabbit? Hares and rabbits are both in the family of Leoridae, but they are separate species. Okay, I'm so sorry. I'm so sorry. They are a separate species. Yeah, it is my habit to always go out of the topic. We were discussing this particular algorithm, that is tortoise and hare algorithm. In this particular approach, what we are going to do is we will have two pointers, slow and fast. A very basic thing in linked list. I know if you are new, I can explain it to you in a very decent manner. Let's say we have slow. It is pointing. First, I let me create my linked list. My linked list is LL stands for linked list. One guy, two guy, three, 4 and 5. Yeah, and our slow will point to 1, and our fast will point to 1 also. What we will do, we'll have a while loop or something like that. We'll iterate slow one time, and fast will move two steps ahead. Slow will move one step each time, and fast will move two step each time. That is why it is called slow, and that is why it is called tortoise and hare algorithm. Yeah, don't even try to remember this algorithm name. Okay, I tried my best to remember this and I messed up, but yeah, please don't try that at home and try it on your risk only. Okay, so while we'll be tracing it, yeah, simple condition that fast should be defined, है ना? How we are going to check that fast should be defined is simply by checking whether fast is not equal to null, and if we are going to move fast next to next, that means two steps, then we need to verify that fast next should be defined so that we can have a pointer on next of next. Did I made any make any sense there? If not, I'll try to explain it earlier while I was when I'm going to write the code. Okay, so what we are going to do is initially for the case first iteration, what we will have is slow will point to 2, okay, and fast will point to 3, because fast is going to move two steps. And in the second iteration, yeah, like in the second iteration, slow will be on the 3, and fast will be fast will be on 5. And here, when fast will be equal to 5, in that case fast next will be undefined or null. Yes, because overall our linked list is 1 2 3 4 5, and fast next will be null, and in that case our while loop will break, and you guys will be surprised to know that our slow is pointing to the mid of the linked list. Yeah, it is on 3. Yeah. So I think we have got our solution, or we have figured out our algorithm. We are going to use this particular thing to resolve our query. Okay, let's implement this. Writing code is always easy. Trust me. Trust me. Figuring out what to write is way much harder to write code. Even I can pass this thing to gpt can write code for me, and I can verify, okay, you have used this is the la la la, and I can just copy paste it to here, and it works for me, it works for you. But figuring out what to write is very important. Okay, now we have figured out what we are going to write. Let's just try to implement. And if you guys faced any issue in that, please do mention me on LinkedIn, or please do write a comment in the comment box so that I can explain it to you earlier. But I'll try my best to uh, ताकि वो ना हो. Okay, so we are going to have what we are going to have two pointers. First will be slow, that will be pointing to the head, and we will have fast as well, that will point to head again. Yeah, yeah. And we'll start our while loop. That while loop will confirm whether our fast should be not equal to null, and our fast next, because we'll have a next pointer on this fast next, should also not be equal to null. This is the case, and in that case, what we are going to do is we are going to just move slow to slows next, yay, and fast will move to fast next, that we have checked is not equal to null, to next. Because having a next pointer on a null, let's say we if we do not have this condition, in that case, in this particular example that I explained, 1 2 3 4 5, when the fast was on 5, okay, then in that case, if I haven't checked that fast next is not equal to null, then in that case I will have fast next and then next, means nulls next, that will be a blunder. Okay, and that we do not want to occur here. That is why we have already checked, okay, fast next is defined, and then we are going to have a next pointer on fast next. Okay, yeah, yeah. This is the approach. And yeah, then we'll return slow. This is I think this should work. This is here, and rabbit and hare algorithm. Yeah, okay, let me just click on run and run code. Fingers crossed. Hmm. हम तुम कितने पास हैं, कितने दूर हैं चांद सितारे, सच पूछो तो मन को झूठे लगते हैं ये सारे, बड़े सच्चे लगते हैं ये धरती, ये नदियाँ, ये रहना और तुम. ignore if I have sang the any wrong lyrics. Yeah, it has been accepted, and I think yeah, it works. Let me check. Yeah, so it works basically, and its overall time complexity will be O of n. Hmm. Mhm. Mhm. Yes. So let me know if you have any issues in this particular problem statement. I'll try to be uploading more videos. I mentioned this a month ago as well, but yeah, I'll try my best to upload more frequently. Bye bye, guys. See you in some other video. Till then, stay hydrated.